Welcome to my channel. I am Dr. G. Soundra Pandian. I will be presenting you this video titled Japan PCS versus China PCS for BESS. The hidden truth behind cost, safety and fires. What is BESS? BESS is equal to Battery Energy Storage System. BESS components are lithium batteries, the BMS, that is Battery Management System, the PCS, Power Conversion System or DC to AC converter or inverter, and the EMS, Energy Management System. What are the functions of the BESS? The functions are backup power, peak shaving, load shifting, renewable integration, and grid services. We do not want the diesel generator. We want to replace the diesel generator with a BESS. What are the problems with the diesel generators? The high fuel cost, the maintenance problems, the startup delay, pollution, and regulations. The video shows a UPS. UPS stands for uninterrupted power supply. We do not want UPS also. Why? The designated backup is in minutes and not in hours. Typically it works maximum 1 hour or even half an hour only. And we use the old battery type, that is lead acid batteries. And third, it has poor efficiency, 90 to 92%. And 4, no energy intelligence. It doesn't give peak shaving, it doesn't give grid interaction, and it doesn't give revenue generation.
Container I was going to show you, this one is 1.075 megawatts. This is all-in power, 1 megawatts container. It's
My video is to educate you to know which PCS is cheap and best, Japan PCS or China PCS. Don't skip, watch till the end to know.
20 feet container. It contains control systems, transformer, and firefighting system, and battery clusters, 5 battery clusters. Here is the interior view of this transformer, and this one is the firefighting system. Okay, a little mess. Okay, and this one is the battery cluster. We have 5 of them. Each of them is 215 kilowatts. So 5 of them total is 1.075 megawatts. Each of the battery cluster including 15 server rack batteries. And down below there's one high voltage control box. You can switch on and off from this control box for this cluster. You have 5 of them, and all together is 1.075.
So out of the 3 things, that is diesel generator, online UPS and BESS, we see that BESS is the best. It has 0 millisecond start time. It uses grid or solar energy for the backup. It has no noise, that is silent. It has no pollution or emissions. It has very low maintenance. It has very high efficiency, up to 98%. It has smart control and it has grid services. which BESS is cheaper, Japan or China? To know this, let us take an example. Assume that I want to make a PCS of 300 kilowatt to make a BESS of capacity 1 megawatt hour. So if I want to do it from the China models, what is available in India, and if I select Solis inverters, the maximum power available in Solis inverters in India is only 50 kilowatt per box. So to achieve 300 kilowatt, I will have to parallel 6 number of 50 kilowatt PCSs. Now if you look at the pricing, one 50 kilowatt unit costs including GST 5,72,250, and 6 PCSs total will cost me 34,33,500. Now why only choose Solis? There are other Chinese companies. Okay, if I try to look at the possibility of bigger power capacity PCS, like the water cooled systems from Sine NG, Sungrow, Narada or Envision, from internet I may find that the price may range for a 300 kVA PCS somewhere around from 20 lakh to 33 lakh rupees, of course plus customs duty plus taxes. The problem here is the Sine NG type of PCS provide 3-phase output voltage which is not 400 volt but is around 690 volt. So the 690 volt output cannot be connected to the Indian grid directly. So this is one disadvantage. So therefore we will go for Solis, and the pricing is around 34.33 lakhs. Now if I go for a Japanese product, and if I look at the 300 kilowatt option, I saw that I can get a PCS from Japan for 23 lakh only, and there is no botheration of parallel connections of 6 inverters. As you know, the Japan brand products are highly reliable, and I was earlier thinking that it will be very costly, but here we see that it is not so. It is in fact cheaper. So we concluded that Japan PCS for a 300 kilowatt system is low cost as well as very reliable. So therefore it is winning over the China PCS. Now in this slide we again see the documentation and certification part of the Japanese PCS, and we see that Japanese PCS will be satisfying many of the certifications like IEC, EU, ISO, IEEE, much more than what China PCS may offer. Let us look at the features of the 300 kilowatt Japanese PCS. Okay, this Japanese PCS is not an online UPS but a bidirectional inverter with grid side features. It has typically better documentation. It has international grid code support. The standard committees like IEC, IEEE, it is complying. It has strong BMS, EMS integration libraries. I should point out here that because the PCS does not have automatic current limiting feature as a function of temperature, an external EMS is required which will do the job by communicating simultaneously to both the PCS as well as the BMS. Okay, next point, stable and predictable behavior under fault conditions. And the last point, which is very good, is that it is mandatory to provide HVAC for cooling the both PCS and the LFP batteries. The cooling avoids fire in the lithium batteries and also allows proper charging at ambient temperatures above 45 degrees C. A particular feature of Japan PCS is that it has got only one DC port for connecting to the batteries. I myself has tested a Japan PCS where it was drawing 1000 ampere discharge current from batteries at 614 volt. So such a large current at one point is one issue. If you compare this PCS with China PCS, the China PCS will have more than 2 DC battery ports, and therefore the currents are distributed at different DC ports or battery ports in case of China PCS. But in the Japan PCS, so we have this particular feature of large currents concentrated on a single DC port meant for the batteries. Then the Japanese PCS, they do not have the CAN signaling availability, and the PCS cannot adjust the battery current, that is, it cannot do the current derating automatically if the BMS signals above 45 degrees C battery temperature. But fortunately, the Japanese PCS also comes with a strong EMS, that is energy management system, which is connected via RS485 or any other serial port to the PCS, and the EMS is also connected to the BMSs of the batteries, and the control logic in the EMS does everything what is required. Now, one advantage of concentrated current at a single DC port is that we will have less number of racks of batteries and less number of high voltage boxes, which are high voltage BMSs, which are to be paralleled, because the high voltage box is unreliable, and since we will have fewer number of the high voltage boxes, so we have an advantage here in the Japan PCS case. Now, the last point, which is not good, is direct paralleling of battery racks outputs on the PCS DC port bus bars may lead to large circulating currents in the batteries and may reduce the battery life, as the cell balancing in the packed BMSs is generally weak, that cannot ensure same voltages at the different rack BMSs to stop the circulating currents. This is a battery problem and not a PCS problem, and this battery problem is there for both Japan PCS as well as for China PCS. So therefore, the fire possibility in BESS is there. For lower power capacity PCS, for example 15 kilowatt or 30 kilowatt or 60 kilowatt, I will not recommend Japanese PCS, because the Japanese PCS in this case will be costlier than the China PCS. So here for low capacity, the China PCS is a clear winner. For example, I have listed the features. The China PCS is rich in features like derating of battery current with temperature, zero export to CT, bidirectional grid port, auxiliary DC input from DG set, wall mountable, etc. There are so many features, good features in the China PCS. When I say China PCS, for example, from Day or Solis, up to 16 ports, up to 16 PCSs can be connected in parallel. Every China PCS like Day or Solis provides 2 separate DC ports for battery input for 50 kilowatt to 125 kilowatt inverters. This with multiple PCSs in parallel makes the current level at each battery DC port small and bearable. That is, when we parallel many China PCSs and each PCS has 2 isolated DC battery ports, so there will be many DC battery ports available and many racks of batteries which are all isolated, or connected, and so we have an advantage here because the current is now distributed, and also there will be no circulating current because the battery racks are isolated. This stops the circulating current among the racks. This is a very big advantage in the case of China PCS. This multiple DC ports removes the need for parallel connection of battery banks by using several isolated battery banks. So that is a very clear advantage. That is, we will have a lower probability of fire because of that, because there is no circulating current in this case. Another big advantage in the smaller capacity PCS of China is that the HVAC is not required. You can just wall mount the China PCS. Of course, this is possible at only lower power levels, lower capacity BESS. What are the disadvantages of a China PCS? Number 1, the maximum power capacity of a PCS is limited to 80 kilowatt for Day and 50 kilowatt for Solis. We may have power levels of 250 kilowatt, 400 kilowatt and 430 kilowatt in the case of Sine Energy type of PCS. But the disadvantage there is the AC output for 3-phase is 690 volt and not 400 volt. So we cannot connect these PCSs in parallel to the grid. The second disadvantage is that we are having minimum 2 DC battery port per PCS, and for n number of PCSs in parallel, there will be 2n number of DC ports and 2n number of high voltage BMSs, that is high voltage boxes. So when you have too many high voltage boxes, we have a disadvantage because each high voltage BMS uses unreliable relay contacts for switching instead of MOSFETs, and a manual switch in each high voltage box, if gets tripped, needs manual resetting. With tens or hundreds of such manual switches, if left unattended, may lead to fire. These switches can be turned off by software control but cannot be turned on by software. That is, we need a person to go physically to reset these switches. This is a very major disadvantage of the high voltage type PCS of China. Okay. I have seen in some cases people use parallel connected racks to the single DC port of the China PCS. So whenever you parallel racks, there will be problem of circulating currents, which will reduce the battery life. So the last point, higher cost if many small PCS units are paralleled and therefore cannot beat Japan in quality, reliability and price. The low voltage PCSs from China are superior. When I say low voltage PCS, I mean that the battery voltage is either 48 volt or 51.2 volt. Such systems are unbeatable by Japan PCS, but this is possible only at lower power capacities. So you have many advantages. One, low priced. Two, does not use the high voltage boxes type BMS with manual switch. You can just install and forget this PCS with no worry about any manual resetting of switches for months, as the PCS is highly intelligent and does not need extra EMS. It has scan signaling towards the BMS and automatic derating of battery current is done. Rich features on the grid side including zero export to CT, peak shaving, etc. are available. Maximum output power of these low voltage PCS when in parallel, 16 of them can be paralleled with the 20 kilowatt maximum. This comes to a PCS maximum capacity of 320 kilowatt and energy capacity of say 4 times, which is 1.28 megawatt hour. For PCS capacities less than about 80 kilowatt, the low voltage PCS solution is highly recommended. The last point is very, very important. For higher capacity up to 320 kilowatt, the low voltage PCSs in parallel can provide a BESS without fire. So we have no risk of fire if we built a BESS by using the low voltage PCSs, which does not have manual relays in the BMS. We can avoid the fire in the BESS completely. So we have no circulating currents and no high voltage box relay. So we saw that the low voltage type China PCS is excellent. We also saw that high capacity Japan PCS is better than China PCS. Now let us see the limits of Japan PCS. 1. The typical PCS capacity is 100 kilowatt to 1000 kilowatt. Storage capacity limit may be 1 to 4 megawatt hour. HVAC is a must. EMS is a must. Lower price and higher reliability of the PCS is possible only at higher capacities. The high voltage boxes on the battery banks are a problem with high circulating currents and reduced battery life. So this problem of course is there for both Japan PCS as well as for the China PCS at higher capacities. So Japan must redesign the high voltage BMSs. At lower capacities of less than 200 kilowatt, the PCS may appear expensive. I discovered that the major reason for fire in the BESS is due to the parallel connection of racks of batteries. Large circulating currents in the batteries and in the high voltage boxes in fully charged condition is expected to be the major reason of BESS fire. The circulating currents are not transient. I found the circulating currents to be continuous in nature that can damage the batteries apart from causing fire. My company, Dr. G.S. Pandian R&D LLP, has filed one patent on stopping the circulating currents in the racks of batteries. I am preparing a second patent on the design of a high voltage BMS by removing the manual switch and relays in that high voltage box. If any company wants to help me in the above patent work, and if they can give a funding of rupees 1 crore, we can develop the work jointly and my company can share the patent rights for that company. They may contact me in my email ID. Conclusions. 1. Japan PCS is recommended for the range 200 kilowatt to 1000 kilowatt. 2. China PCS with no fire risk. These are the low voltage China PCS is recommended for the capacities of BESS of 15 kilowatt, 30 kilowatt and 60 kilowatt. 3. China PCS with no circulating current. These will use the high voltage China PCS for the capacity ranges 50 kilowatt to 200 kilowatt. Point number 4, the high voltage box must be redesigned by removing relays with MOSFETs and by removing the manual switch.